Hello, welcome. This is CIA 9709, May June 2010, Mechanics Paper 41. There are something around 7 questions. We shall try to solve all the 7 questions. So, first question, it says a car of mass is 1150 kgs, travels up a straight hill inclined at an angle 1.2 degrees. So, I draw the diagram, inclined at an angle 1.2 degrees. The resistance of the motion of the car is 975. So, there is a car over here. This is a car. The resistance of motion in the backward direction is 975 newtons. The acceleration of the car at an instant when it is moving with the speed 16. Find the acceleration when it is moving with the speed 16 meters per second, and it is working. The engine is working with the power of 35 kilowatt. So power is equal to 35 kilowatt. Then the velocity is equal to 16 meters per second. So we know that driving force is equal times velocity. So driving force times velocity will be equal to the power. So power was 35,000 or 35 kilowatt was equal to driving force times 16. So from that I get the driving force as 35,000 divided by 16. Now that's going to be the driving force. I draw over here driving force. Now we know that forward force minus backward force is equal to ma. Now the mass is 1150. So immediately what are we going to do? Draw the free body diagram. This is 1150 g, and downwards will be 1150 g sine 1.2. Now the normal force is normal reaction is balanced by 1150 g cos 1.2 is balancing the normal reaction. So forward force minus backward force is equal to ma. We use that concept. Forward force minus backward force is equal to ma. So the forward force is my driving force, which is 35,000 divided by 16, minus backward force is 1150 g sine 1.2 degrees, and backward force is the resistance force also 975 is equal to ma 1150 a. So simplify this. This should be giving you a as in three significant figures 0.845 meter per second square. That's going to be the answer for the first question. Second question, it's a diagram, velocity time graph. The graph shows the velocity time graph for the motion of a machine cutting tool. The graph consists of 5 line segments. So there are 5 line segments. So we shall mention those 5 line segments. First one, different color so that it is easy to identify. The second one, then the third one, and the fourth one, finally the fifth one. So these are the 5 line segments. The total move is nothing but what? The tool moves forward 8 seconds while cutting and then takes 3 seconds to return to the starting position. Find the acceleration of the tool during the first 2 seconds of the motion. So acceleration during the first 2 seconds. So initial velocity is 0, final velocity is 0.18, and time taken is 2. So v equal to u plus 80. So I use 0.18 is equal to 0 plus 2 times a. So a is equal to 0.09 meter per second square. That's going to be the answer. Now the first part is done. The distance the tool moves forward while cutting the tool while cutting. So distance move forward. So this entire distance, area of the trapezium. Area of the trapezium is going to be the entire distance. So half times sum of the parallel sides. So the parallel sides you can see it is 8 over here and it is over here 4, 8 plus 4, and the height is 0.18. So half times 8 plus 4 times 0.18. Simplify that, 1.08 meters. The greatest speed of the tool during the return to its starting position. Greatest speed. So what is this greatest speed? So what is the basically height of this triangle? So we know that as it has went 1.08 forward, so it has to backward, coming backward, it has to have same 1.08. So area of the triangle should be equal to, so the distance traveled during the return journey should also be equal to 1.08 meters. So it should be the area of a triangle. Area of a triangle formula is half times base times height, should be equal to 1.08. Half times base. What is the base? It took from 8 seconds to 11 seconds. So means 3 seconds is the time. Height is at velocity v equal to 1.08. So 3v is equal to 2 times 1.08. V is equal to 2 times 1.08 divided by 3. V is equal to 0.72 meters per second. That's going to be the answer. Question number 3. A small ring of mass 0.8 kgs. So immediately draw 0.8 g. Is threaded on a rough rod which is fixed horizontally. The ring is in equilibrium acted by a force of magnitude 7 newtons upward pulling at 45 degrees to the horizontal. Show that the normal component of the contact force acting on the ring is 3.05 newtons. Three significant figures. So this 7 newtons is acting in this direction. So I resolve 7 newtons, one horizontally and one vertically. So I can say that this becomes 7.5 cos 45 and 7.57, not 7.5, it is 7 cos 45, and this is 7 sin 45. Similarly, there is a normal reaction R which is acting upwards. So what am I going to do? So upward force is equal to the downward force. Upward force is equal to downward force. So upward force is R plus 7 sin 45 is equal to downward force is 0.8 g. So from here R is equal to 0.8 g minus 7 sin 45. 2 by calculator, he should be able to get in three significant figures, 3.05 newtons. The ring is in equilibrium, find the coefficient of the friction. So there is a frictional force which is acting backwards because it wanted to move forward, so it will be acting backwards. So which is the frictional force? So that frictional force should be equal to, because it is in equilibrium, F means frictional force. The frictional force should be equal to 7 cos 45, which is nothing but what? Mu r is equal to 7 cos 45. Now mu r value is 3.05 is equal to 7 cos 45. From there, if you get it out mu value, which is 7 cos 45 divided by 3.05. So you can take the calculator, keep the mode of the calculator in degrees. 7 times cos 45 divided by 3.05. So this should be giving me something around 1.62. So mu value is 1.62 in three significant figures. So that is question number 3. Now coming to question number 4. The coplanar forces of magnitude 250 newtons, 160 newtons, 370 newtons act on a point O in the direction shown, where a alpha is the angle is such that sin alpha is equal to 0.28, cos alpha is equal to 0.96. Calculate the magnitude of the resultant of the three forces. Also calculate the angle that the resultant makes with the x direction. So I am going to resolve this 250. This is 250. One horizontally and one vertically. So immediately you can write 250 cos alpha and 250 sine alpha. So now along x direction, the forces along x direction. What are the forces along x direction? Will be 250 cos alpha plus 160. These are the along x direction. So that will be 250 cos alpha is 0.96 plus 160. Along y direction, it will be 370 in the upward direction, 250 sin alpha in the downward direction. So it will be 370 minus 250 sin alpha, which is 370 minus 250 sin alpha is given as 0.28. Now the resultant will be square root of x square plus y square. So that will be square root of, take the full calculated replace, 250 times 0.96 plus 160 whole square plus 370 minus 250 times 0.28 whole square. Simplify by the calculator, we should be getting it out somewhere around 500 newtons. Now angle is also been asked. So for angle, what are we going to do it out? I'll quickly add a page. Tan theta is equal to y upon x. So theta is equal to tan inverse y upon x. So which is tan inverse y value is 350 minus 350 minus 370 minus 250 times 0.28. X value is 250 times 0.96 plus 160. Simplify by calculator, in degrees mode 36.9 degrees, or if you want to in radians mode 0.644. That's going to be the answer for question number 4. Question number 5. P and Q are fixed points on a line, a greater slope of an inclined plane. So there is an inclined plane. The Q is at a height of 0.45 meters above the P. So point Q is over here, point PO is over here. The height is 0.45. So what am I going to do? Immediately I'm going to draw a height. So this height is 0.45. A particle of mass 0.3 kg moves upwards along the line PQ. So it is moving upwards along the line PQ. Given that the plane is moved and that the particle just reaches Q, find the speed with which it passes through P. So it passes through P. So it is over here. Now it reaches Q and stops there. It reaches Q, just reaches Q. Find the speed with which it reaches this one. So from P to Q. So from P to Q. So what is happening from P to Q? So we are not filled. What we can do it out is, easiest method to do is we use work energy principle. What is that work energy principle? Total work done is equal to delta KE plus delta PE plus work done against friction. WDF means work done against friction. TWDE means total work done. KE is kinetic energy, PE is potential energy, WDF is work done against friction. Work done against friction is 0 because it is a smooth plane. Total work done is also 0 because we are not pulling it. So only we have that delta KE plus delta PE is plus 0 is equal to 0. So delta KE means change in kinetic energy plus change in potential energy is equal to 0. Change in kinetic energy means final kinetic energy minus initial kinetic energy for the ball plus final potential energy minus initial potential energy for the ball is equal to 0. Final kinetic energy is 0 because it is stopping, minus initial potential energy is half times m times, maybe initial velocity is u square. Final potential energy is m times g times h. It is at a height of 0.45 above the P. So if we consider P as 0, so it is at a height above 0.45, and I consider initial potential energy as 0 because m times g times height is 0 is equal to 0. From this, so I'll be getting it out, m times g times 0.45 is equal to half m u square. Then from there m and m gets cancelled, so u square is equal to g times 2 times 0.45. U is equal to square root of g is 10 times 2 times 0.45, which is equal to 9. So u is equal to 3 meters per second. Now it is given that instead the plane is rough now. The particle passes through P with the same speed as found in part A and just reaches a point R, which is in between P and Q. It reaches R. The work done against the frictional force from P to R is 0.39 joules. Find the potential energy gained by the particle from P to R and hence find the R above this one. So same, total work done is equal to delta KE plus delta PE plus work done against friction. Now, total work done is still is going to be 0. Final kinetic in delta Ke means final kinetic energy is 0 minus initial kinetic energy is half times m times. He says that it moves with the same velocity, so minus 3 square. Final potential energy m times g times h, I don't know, minus initial potential energy we'll consider as 0 plus work done against friction. How much is the frictional force? The work done against the frictional force is 0.39. 0.39. So I use this formula. So has he given the mass of the particle to move that one? The mass of the particle is 0.3 kgs. So that will be much more easy for us to solve it out. So, so from there, what do I get it out? 0 is equal to minus 1 by 2 times 0.3 times 9 plus 0.3 times 10 times, what is the height we don't know, plus 0.39. So from there, I should be getting the value of 0.3 times 10 times h is equal to 1 upon 2 times 0.3 times 9 minus 0.39. So this is 3h is equal to 0.15 times 9 minus 0.39. So take the calculator. 0.15 times 9 minus 0.39 gives you 0.96. So h is equal to 0.32 meters. So what is the height it has reached? It has reached 0.32 meters. What else is being asked? Find the potential energy gained by the particle in moving P to R and hence find the height. So we have found the height. The potential energy gained by the particle. Potential energy gained by the particle. This part is going to be this is a potential energy. So he is referring to this is a potential energy. So this is a potential energy. So this value was 0.96. So potential energy gained is equal to 0.96 joules. That's question number 5. Coming to question number 6 now. The particles A and B, the masses 0.2 kg and 0.5 kg respectively, are connected to a line in extensible string 2.8 meters long. So 2.8 means this has to be 0.7 meters because already 2.1 meters is there. The string passes over a smooth pulley at the edge of the rough horizontal surface, which is 2 meters above the ground. The pulley is 2 meters above the floor. The particle A held in contact with the surface at the distance of 2.5 meters from the pulley, and the particle B hangs freely. The coefficient of friction between the A and the surface is 0.3. Particle A is released and the system begins to move. Find the acceleration of the particles and show that the speed B immediately before it hits the floor is 3.95, correct to 3 places of decimal. So for B is 0.445, so 0.45 g acts downwards. For A, 0.2 g. Then tension always towards the pulley. So forward force minus backward force is equal to ma. For A, the forward force is tension minus backward force. There is a friction minus friction is equal to ma 0.2a. For B, forward force is 0.45 g minus tension is equal to 0.45 a. So I got this one. Now what I can do is that frictional force is equal to nothing but what? Mu r. Mu is equal to how much has been given? 0.3, and r for the A will be over here, which is 0.2 g. 0.2 g. So now what am I going to do? I'm going to take these two equations, solve this. Tension cancels. 0.545 g minus frictional force, which is 0.3 times 0.2 g, is equal to 0.65 a. Simplify that. From there you should be getting the value of a. So which should be equal to 6 meter per second square. Now once I get the acceleration, find the speed of B immediately before it hits the ground. So V is equal to U plus AT, or V square is equal to U square plus 2AS. So V square is equal to U square is 0 square plus 2 times A is 6, and distance. So what is the height it is going to be doing? Though it is at 2 meters, we initially know that it is was 0.7 meters. So remaining will be 2 minus 0.7 meters. So height it is going to fall down is not 2 meters, 2 minus 0.7 meters. So from that V is equal to square root of 12 times 1.3. That you do by calculator, it should be 3.95 meter per second. Given that the B remains on the floor, find the speed with which A reaches the pulley. Now what happens is, let us draw the diagram over here. Draw a straight line. It's a table. It's a pulley, and B hanging over here. B. This is A. Now B falls 1.3 meters. So A also comes up to here. Maybe it comes up to here. It comes up to here. I can draw much more bigger. It comes up to here as 1.3. A comes up to here. This is also 1.3 meters. Now the velocity of B over here was 3.95 meters per second. Because it is connected with the same string, the velocity of A over there also will be 3.95 meters per second. So this is A prime. So at A prime, the initial velocity is 3.95 meters per second. Now he is asking where it will come and stop. So what is he asking? Find the speed with it reaches the pulley. Final speed is asking. So the remaining distance is 0.8 meters because total is 2.1. 2.1 minus 1.3 is 0.8 meters. So distance it travels is 0.8 meters. Now we need to know the deceleration. So we have learned forward force minus backward force is equal to ma for A. So there is no forward force, minus backward force is my frictional force, is equal to ma. M is nothing but what? 0.2 A. So 0 minus mu r. Mu is 0.3, r is 0.2 g is equal to 0.2 A. 0.2 gets cancelled. acceleration is equal to deceleration is equal to minus 3 meters per second square. Now I know that one, then I use v square is equal to u square plus 2as. So u square is 3.95 square plus 2 times a is minus 3 and s is 0.8. So from there v is equal to square root of 3.95 square minus 6 times 0.8. Do by calculator, it should be something around 3.29 meter per second. That's going to be the answer. Now coming to question number 7, the last question. The vehicle is moving in a straight line, the velocity v meters per second at a time t seconds after the vehicle start is given by this one. V is equal to a times t minus 0.05 t square. V is equal to b upon t square, where t is greater than 15. Less than 15 is this one and greater than 15 is this. The distance traveled by the vehicle between t0 to t15 is 225, means distance when I do the velocities integration from 0 to 15, I should be getting 225. So integral of a times t minus 0.05 t square dt should be equal to 225. The limit should be 0 to 15. So a times t square by 2 minus 0.05 t cube by 3 from 0 to 15 is equal to 225. So 0 lower limit is 0, so no need to substitute, only the upper limit. A times 15 square by 2 minus 0.05 15 cube by 3 is equal to 225. Simplify this one. A is equal to 225 upon 225 upon 2 minus 0.05 times 15 cube upon 3. Do by calculator. This should be giving you the answer for A is 4. And show that B is 3375. Now we have to prove that the value of B is 3375. So for that, how should I be able to get the value of B? Now we know that the value of A is nothing but what? 4. So we can see that at 15 it is the same. At t equal to 15 it is A, and at t is equal to 15. So t equal to 15 is common. So when I plug in t equal to 15 in A, that is 4 times 15 minus 0.05 times 15 square should be the same as when I substitute 15 in B also, which is B by t square, which is B upon 15 square. So I got that value because we can come to see that at t equal to 15 the velocities are the same. So I find the velocity at t equal to 15 using the first equation. I find the velocity using the second equation at t equal to 15 and equate both. From here we can get the v value as 3375. Coming to the second part, find an expression in terms of t for the total distance traveled by the particle when t is greater than or equal to 15. So I am going to do the integration of the second part, vt v dt. So it becomes b t by t square dt. So it becomes b t power minus 2 dt. So it becomes b t power minus 1 by minus 1 plus c. So b value was 3375 upon t minus plus c. Now we know that this is a distance, but at 15 at t equal to 15 the distance is equal to nothing but what? 225. So 225 is equal to minus 3375 upon 15 plus c. This should be giving you the value of c, which is 225 plus 3375 upon 15. So 3375 divided by 15 gives me 225. 225 plus 225 is 450. So which will be giving me the value of C as 450. So my equation will be 450 minus 3375 upon T. This is the equation of the distance. Find an expression. Find the speed of the particle when it has traveled a distance of 315 meters. So now that is more than 225. So we take the second equation, and he says that the distance is 315. So from there, I get the value of t 3375 upon t is equal to 415 minus 315. So t is equal to 3375 upon 450 minus 7, 315 is 135. So when I divide that, I get 25. T is equal to 25, but he's asking for velocity. Velocity is v upon t square, which is 3375 upon 25 square, which gives me 5.4 meter per second. So that's going to be the answer. So that completes the paper. See you in the next paper. Bye.